Okay, welcome back. We're just going to take a look at some word problems for sine law and cosine law. Before we get into that, we just got to look at the whole idea of geographical bearings. This is just a way of describing the direction that different things are going, boats, planes, people, cars, whatever. You might see in some word problems. It's good to know what it means, because without it you can't set up the diagram appropriately. If you've taken any kind of physics, you may have seen this type of notation before. We're talking about the directions of certain things, but again, it's new for most of us here. So if you see in a problem, for example, that a plane is traveling north 40 degrees east, if you're looking at it top down, what it means is traveling 40 degrees east of north. So on a diagram, we'd go north and then move 40 degrees to the east, and this would be the direction that this particular plane is going. Okay, so again, you go, the first direction is north, and you move 40 degrees to the east, and there's your direction. So for west 40 south means we go west first, and then 40 degrees to the south. Okay, and last but not least, south 40 degrees west means south 40 degrees to the west. I know that's not to scale, but whatever. Okay, so just keep that in mind if you ever see that in a problem. And when might you see it in a problem? Hey, right about now. So we have a boat leaving a marina, and it goes in a direction south 40 degrees west for 25 kilometers. And he's going to change the course of his boat and go north 3 degrees east for 20 kilometers. I'm trying to figure out how far the boat is from the marina when it's finished that. So try on your own to draw a picture first. Once these pictures are drawn, it's usually just a matter of just using the right equation and just solving it from there. But coming up with the diagrams can be a little bit tough. So just try and think it through, get a picture for yourself, and push play when you're ready to see it. Okay, let's try and put this diagram together now. So we're leaving a marina and we're going south 40 degrees west. So what that means is I go south 40 degrees to the west, so around there, and that's going to be the first direction he's going. So if this is the marina up here, south and 40 degrees to the west, and that's where he winds up. This is 25 kilometers he goes for. Okay, and then he adjusts the course of his boat and goes north 30 east for 20 kilometers. So that's north 30 degrees to the east. Let's do something like this. And it's only for 20 kilometers, so not as far as that 25. So let's just do it right around there. So just filling this in. So it's north and then 30 degrees. And then what does it say here? Oh yeah, 20 kilometers. So after that turn, driving for a little bit, he winds up there. We want to find out how far he is from the marina. So we want to find that distance right there. Okay, so this is the diagram for this particular situation. And once we have this drawn, we just got to figure out if we have enough information to be able to solve for this distance. Now, if you look at this triangle, we have two of the lengths. We have the 20 kilometers here, the 25 kilometers here. But we actually right now have no angles inside the triangle. So we got to do a little bit of geometry and try and figure out what's going on in there. Now, what worked for me is I look here, okay, I've got a 40-degree angle here, and if I assume that this is vertical, which it is, and that this is vertical, which it is, okay, then we have a little bit of a Z pattern here. That should mean that this angle right here, the 40, and this whole angle right here, again from this Z pattern, should be the same. So if this amount's 30 and the whole thing has to be 40, that means this little angle inside the triangle here has to be 10 degrees. Okay, so that now gives me an angle inside the triangle, and I can actually use something to solve for it. Now, is it going to be sine law or cosine law? Well, do I have a side angle pair? I don't here. Okay, I have no angle and the side across from it, so I have to use cosine law. I'm solving for side D, so my equation is going to be d squared. My other two sides are 20 and 25, so 20 squared plus 25 squared minus 2 times 25 times 20 times the cosine of 10 degrees. Okay, so once we have the diagram, we set up our equation. We have to just solve for D. You should wind up with about 6.34 kilometers when you're finished. Okay, let's give the next one a go. So this one's definitely pretty complicated to try and set up. Take a minute, read through it, and again, with a partner on your own, take a minute and try and sketch it out, and when you're ready, we'll go through it together. This is another problem with a lot going on, a lot of information to try and get through. It might be hard to visualize. The key thing here to get started with the diagram is actually not the first sentence, but the third sentence right here where it says the queen is north 45 west of the king. That tells you the original orientation of those two boats. So wherever the king is, and let's just say it's somewhere down here, call that K, the queen is north 45 west of it. So that means go north 45 degrees to the west approximately, and that would be where your queen boat is located. Okay, and the angle it's going to make here again is going to be 45 degrees. And it tells you how far these two ships are apart from each other. They're 50 kilometers. And with that, it actually makes it a little bit easier to set up the rest, because now the queen sees a distress flare at south 5 degrees east. So somewhere to the southeast of the queen, it sees a distress flare. The king sees the same flare at south 13 degrees west. So the king sees a flare at southwest, the queen sees it at southeast. The only way that can happen is if the flare is somewhere located down here. Okay, so I'm going to draw the flare somewhere down here. And let's just finish up our diagram here. So the queen sees it there. The king sees it there. And we just got to put in our angles now. So the queen sees it at south 5 degrees east. So that little angle in there is 5 degrees. The king sees it at south 13 west. So that gives you a 13-degree angle in there. And we've used all the information we have. Now, if you look at this right now, we don't have enough to solve it. If you look inside the triangle, we know one of the three sides, and we actually have none of the angles. So you need to think about how we can find out different angles inside the triangle. Okay, I'll let you think about that for a sec, in case if you haven't done so already. And so pause it and push play when you're ready to go through it. Okay, so the first way you can find an angle is, again, there's multiple different ways. You can actually find whatever angle you want in here using the right geometry. If you look along here, these three angles are all along a straight line, so they're what we call supplementary angles. So that means that all these three angles have to add 180 degrees. So this means this angle K right here would be 180 degrees minus 13 minus 45. Which, if you do a bit of quick math on it, tells you it's going to be 122 degrees in there. Okay, so that gives us one angle. And again, depends which angle you're trying to find next. If you want to try and find this angle right here, the Q, we can use, similar to what we did in the last one, we can see a Z pattern here. So this right here, this line right here, and this line right here are parallel to each other. So you have a Z pattern which tells us that, I'm just going to choose a different color here, that this angle right here, the 45 degrees, is equal to this whole angle right here. So this whole angle is 45, this little part's 5, which means the rest right here has to be 40 degrees. Okay, and then you can use the fact that all the angles add up to 180 degrees in a triangle to find the angle F is going to be 18 degrees. Okay. One thing you could have done if you didn't see this pattern up here or this pattern down here, could have used another Z pattern. You could have had 5 degrees forming a Z pattern here with this vertical, say that this has to be 5 degrees, and a Z pattern with this one, say that this has to be 13 degrees. So another way of getting the 18-degree angle down there. So whichever way works for you, but either way you can find all three angles inside the triangle. So what we're looking for in the end is the distances. So if I call this one, I don't know, D1, this one D2. Okay, what law do I use? Well, I have a side and angle across from it, so I have the 50 kilometers and the 18-degree angle here. So I can use sine law to solve whatever other side I want. Okay, so I'll let you try that on your own. I'm going to just set up the equations here. So sine of 18 over 50. If you want to find D1, the distance for the queen, you're going to have sine 122 over D1. And I'll do some algebra there to solve for that one. And for the other one, 50, and you'll have sine of 40 degrees over d2. So I'll let you solve those on your own. If you're still not sure about the algebra, just come and ask me, but you should get those two distances for your answers. Alright, let's move on a bit. So we're getting towards the end, a couple more examples to go. You just want to find the area of these two triangles. So think back to grade 7, grade 8, first time we looked at area of triangles, and you might remember that the area of a triangle is base times height all divided by 2. So on the surface it seems like a pretty easy problem. However, you'll notice here that we actually do not have the height. Okay, so if we orient it this way, base is 9.7, but the height is actually this distance right here. It's a perpendicular distance, so we can't use 7.1 as the height. And there's no way we can orient the triangle to get the height without actually having to do some calculations. So it's actually a little bit of a longer problem than it seems. So we have to calculate the height, which means working inside one of these right triangles. Now the problem is, let's say I want to work with this triangle right here, this xz, and I don't know, let's call this q, this xzq. I can't even use Pythagorean theorem in this triangle because I only have one side. I have the 10.9, but this 9.7 is actually for the entire distance, not for just this little piece right here. So I don't have enough information to use Pythagorean theorem, which means I have to use some kind of trigonometry. To use the trigonometry, I'm going to need to have an angle. So let's say I want to try and find this angle right here, angle z, and I'm looking at the whole triangle right here. Let's clear that out of the way for now. I would have to use cosine law, which can be a bit of a painful process, but we have done it before. So if I want to solve for angle z, the side across from z is 7.1. So 7.1 squared. My other two sides are 9.7 squared and 10.9 squared. So we're going to set up our equation here. And all this again is to find this angle z, which we can then use to then, oops, not the best height there, but we want to again find that height. Okay, so take a minute and solve for that. So after a lot of algebra here, you should end up with angle z being about 39.8 degrees. Okay, so that was our first step there. We found angle z. Now we can use SOHCAHTOA to find the height. So this is my opposite side to angle z. 10.9 is my hypotenuse. So sine of 39.8 degrees will be h over 10.9. Okay, so if you rearrange that to solve for h, you'll get about 6.98 meters. Sorry, meters there. So now that we have that height, we can go back to using what we wanted to at the very beginning, which was the fact that area is base times height over 2. Now looking at this whole triangle, the base of the whole triangle is 9.7. We just did a whole bunch of work to calculate the height to be 6.98. And then you're going to divide that by 2. So you should get about 33.85 square meters. Alright, so that was taking a problem from grade 8, a simple area of a triangle, and making it a lot more complicated. Okay, so rounds to about 34 square meters, but about 33.85, depending how many decimal places you keep. Okay, with that in mind, I'd like you to try the next one on your own, and good luck with it. And we'll just finish this up in part, I've lost track of the parts now, but the next part of this video, I'll finish this one up.